So our top 20, we're going to practice this. 3/5 A plus 4/7 equals 1. Now your first thought might be, well, we're solving an equation, so I'll just start by subtracting 4/7 on both sides. But that's way, way, way slower than what I would tell you to do. And I've done this before, so I think there's a few of you that will know how to clear the fraction here. Trent, do you know how to clear the fraction?
Subtract from 4/7.
Do not subtract 4/7. Nope.
No.
We're gonna multiply by something. You were right on that one. Anybody know? Oh, multiply by what?
5/3.
Nope. And don't multiply by 5/3. It makes the equation super complicated because then all of these other things have to have a 5/3 in them. So there's a really simple way to clear them all. Ready? Everybody write this equation out and then times both sides by 5 like this. And notice I distributed on the left side. I could have just made it into a big parenthesis on the left and then had a whole separate step where I distributed it, but I think it's faster to just go like that. And then again, faster if you can handle a double step. I'm going to multiply everything by 7 at the same time. Times 5 and times 7. And do them separately. I know 7 and times 5 is 35, but if you're going to write a 35, that's 2 characters to write. It's better to write a 5 and a 7 multiplied, because watch how cool this is. Cancel, 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 and you don't have fractions anymore. All the fractions are gone. See how cool that is? Turns a really hard fraction equation problem into just 21a plus 20 equals 35. And from there, you just subtract 20 and divide by 21, and it'll be super easy. Do you get I turned a super hard problem into a super easy problem by just one step? I multiplied by 3 and 5. It's super powerful. You're going to be going to calculus next. You know, after pre-calc, that's the next step. And in calculus, they have fraction stuff all the time. And the key, if you're solving something, is to get rid of the fractions. Like, it can be way more complicated than this, but we got to get the simple kind down first. That's kind of the whole point of these top 20s, is can you get the simple kind down first? Here's another one, very similar. Clear the fraction with the technique I just showed you. And if this problem comes up, and I promise you, it will. It's not going to look exactly like this, but we will have fractions and you will need to clear them. The old thing you were taught in the middle school was the whole multiply by the reciprocal, like Trent said, 3/4. Don't do that. It makes things unnecessarily complicated. You have to multiply by a fraction on everything. You don't do that. You multiply by just the denominator. So much easier. Did you know to times by 5 and 3? Did you remember to distribute it to both sides? Both parts here. You know, this part and this part. Notice every single term gets multiplied by 5 and 3. Iris, what cancels on the first part?
3 and the 5.
The 3, and then the 5, good. And then what is this new thing, Iris?
4n plus 2.
Well, you got to times it by 5. See the 5 there?
20n
20n
plus 6.
6 equals, you can do this, 10 times the 3.
30.
There you go. And do you get from there? Any algebraic student would be able to subtract 6 and divide by 20, no big deal. Okay, that is a super powerful strategy. It's on the top 20, and now you're going to be better at that. Next one is multiplying a triple times a double. You have a system for multiplying a binomial times a binomial, but what about a trinomial times a binomial? All right, well, my advice is to just act like, do you get if there was nothing here, you'd all know how to distribute this? You're like, duh, 5x plus 20. Well, that's what you do. Except you also multiply this x here times both of them. And last but not least, this 2x squared times both of them. So I'm going to clean this up because I on purpose just wanted you to focus on the 5 there. Now I'm going to rewrite my 2x squared plus x. 2x squared. Go ahead and multiply this thing all the way out. There will be 6 terms. And then there's like terms that you can put together. And then really, these aren't that hard. Tons of kids get them wrong because they don't know the system. But now you do. It's just one of those little basics that math teachers assume, oh yeah, kids will just have to multiply that, like on a test. And then all of a sudden, some kids don't know how to multiply that. And then they're done. They lose the point. All right. Now some kids ask, can you do it this way? Sure. You can distribute it that way. And then the other one would be like, and you'll get the same exact answer if you do it that way. I call that the giant clam. It looks a little bit like a giant clam. I got to see my first giant clam in Okinawa when I was snorkeling. And if you ever get a chance to go to Okinawa and snorkel, it is amazing. I have been snorkeling in the Virgin Islands, I've been snorkeling in Hawaii, and I've never seen it as cool as it was in Okinawa. It was so beautiful. The water is super crystal clear, and they have things there that you don't see in the other places, like the giant clam. Now, I didn't see a really, really big one. My guess is you'd have to do scuba to be able to get to the really, really big ones. But I saw some small giant clams, and they look kind of like this. The key on those things is to be really, really careful because they're cemented into the rock. Like, they don't move. Because the barnacles and things like that, they are stuck to the bottom. They're not going anywhere. And if you stick your hand in there, which you could, because it looks really enticing. It's like the edge, along the edge of the clam where it's open, you can see in there, and it's super colorful. And if you go and touch in there, it's going to shut, like snap shut, like super quick. And you could get your finger stuck in there. And then the scary part is, what if you're snorkeling and you're underwater? And your snorkel isn't going up to the top anymore, and now your hand is stuck in a giant clam. See how that could pose a problem? So don't touch the giant clams. Very like tempting because they're kind of really cool looking inside. Even like it was like iridescent, like it glowed. It was like saying, please touch here. Realistically, it's hard to even get yourself to touch it before it shuts because it's so sensitive that it shuts before you even touch it. But that has killed people where they got stuck in a giant clam. Okay, anyway, try to add some variety to your life when I'm telling you these true stories. All right, I'd like to get a final answer on this, so I'm going to multiply it out. X times the 2x squared is 2x to the third. I hope you had that somewhere in your answer. X times the x, there was an x squared, but there was another x squared later, so we won't get our final answer till we add it to that. Now there's a 5x, and then this 4 times the 5 is 20, and then the 4 times the x is a 4x, and I'm going to put that right by the 5x. Notice I didn't feel like I had to put them all on one line. I'm like stacking them. And then the 4 times the 2x squared makes 8x squared. And again, I'm stacking them. And then I can put it all together because these are like terms, and so are these. 2x to the third plus 9x squared plus 9x plus 20. Anybody have that before I said it? All right, good work. Any questions? do you get how it's just multiplying? But yet a lot of kids would have got it wrong because you're not used to having a triple times a double. Trinomial times a binomial. All right, and that's what I'm trying to do is prevent you making lots of little algebra mistakes. All of these are coming up. And if you can master these little things, like here's a really common mistake. Kids have this problem and they go, oh, so 2x squared is 4x squared, you know that, and you square it. And then they take this and then they square it, plus 64m squared. And that's kind of close, but it's wrong. You know why it's wrong? Can anybody? Yes.
You have to do another set of the same.
Yes, that's what you have to do. You have to do a 2x plus 8m like this. That's what squared really means. It doesn't mean square each thing. It means times itself. So although that, what we did is going to be part of the answer, the final answer is actually that distributing thing again. And you put all of those together and you get your final answer. Everybody do that, and then I'd like you to check with the kid next to you and see what you guys think the final answer is. And by the way, if you're shoving a choice between xm or mx, it doesn't matter. If the term has an mx or an xm, it's the same thing, okay? Because you can, in math, rearrange things, and it won't matter if you say that it's like 16xm or 16mx. Same thing. Okay, I'm going to pause for a sec. We give that a shot. All right, I have an offer of an answer from a student. 64x, could you read it again?
64m squared.
M squared.
Plus 4x squared.
4x squared.
And
Plus 32x squared at the end? Just x. Okay. All right. Now, I really appreciate your guts in giving me that answer. It isn't right. You got part of it right. But here's the reason I know it's not right. I know at some point you were going to multiply an 8m and an 8m and get a 64m squared. That is true. And I know that at some point you were going to multiply the 2x and the 2x and get 4x squared. So that's true. But this,
Is it xm?
there you go. It's xm. These two give you 16 of your xm's. And these two give you 16 of your xm's, 32xm. Now we're talking. You were just missing one letter. Good job. Okay. So how do we get that again? That last part was this times this is 16xm. And this times this was another 16xm. Put them together, you got 32xm. Now, in what order should you write them? I'm fine with his order. A lot of times people will put this at the end, and that's okay too. We're pretty generous with what order you write them in because they all have a degree of 2. This term has a degree of 2. So does this, it's because it's squared, and so does this because it's squared. All right. Now, these are all algebra basics called the top 20. Open up Schoology right now, and all we're going to do is take that top 20. This is not our first time taking it. So this one's going to replace the previous time you took it and it went in the grade book. Your better score. Hopefully this score will be better than it was before. And that's all I have for you for today.